Hi everyone, here's Simone from Way Studio. Welcome into this new video. This time I want to share with you this patch which you can get in my Patreon, and this video is a walkthrough this project. I recently put my Patreon all for free because it was not going great and I didn't want to keep all the knowledge for me. Other friend published this choice I made and I got an explosion of subscribers. So thank you very much for your attention, and I this is really encouraging me to make a new video for you, and any support is more than welcome. Work is not going great, and if you need me, I'm here. Hey. Okay, so another way to support the page is that I have a deal with this guy, AE Jewish. They actually are offering really good plugin and video material for any of your project, and they are compatible with the most of common video editing softwares. But I told them, hey, I am a real-time guy. Why are you like promoting video through me? Why you choose me to promote this stuff? Because they actually recently had a lot of stuff for DJing. It's actually really cute and nice. And I am working with the selling department, so to make this experience in Touch Designer directly, so you can build a VJ set with these packages really fast. Maybe they are cute. Look at that. They are continuously like adding stuff, so it's very nice. Link is in the video description. You can get you can, if you try some free stuff from them using the link I share, I may get something if you buy. If not, you can use the link, the second link in the video description if you want to buy something from them. Anyway, if you make an account through the link I shared, I may get something once. I don't know, I'm trying. So thank you very much. Okay, tutorial, the real one. Sorry, I need to promote myself somehow. And yeah, we are here. This is this file, you can get it for free. Okay, and once you load it, okay, if you're in Mac, this doesn't work. 99% doesn't work since we're using Flex and the custom GLSL material. So I'm sorry if you're on a Mac, this is not compatible with your machine. So once you open it, okay, the Flex is broken, and you need to reset the bunny. And maybe you need also to link it as well. So we are taking some 3D data from a USD which is attached to the project. You can get it. You can plug anything here, actually, but whatever. We are using this guy. I put a USD on purpose because I think that USD is a really good way to intercommunicate among the 3D application, and I mean 99% of the time, if you compile it correctly, you get the material auto-assigned, which is like bananas and is really cool. So we are actually acting with this guy, which we take with the select sub. Okay. We are then acting with the primitive. I really hope you know the concept of what a primitive is. If not, you should follow the unwrapped series. There we work with geometry in the GPU and you get a better understanding. So here we're actually addressing the primitive. I want to point the tutorial I personally follow, personally not in person, but I follow this tutorial, so to make this example, and is from Denis Novikov, which I admire, and he teaches us how to move a primitive. There are some really cool concept here. Like the first one is that you can set an attribute in the primitive, but you can read it in a vertex shader, and this gets interpolated by default. Mesmerizing. Why is mesmerizing? Super cool. I don't know if I use the right word, but it's really cool because you can set. I'm using this first pause because he was using first pause in his tutorial, and but you can store the center of each primitive. This is given by subclass, and then you can also set the index, okay, which we will use to rearrange a linear to a square, a linear value, we pack it in a square. Also, this one is explained in the unwrapped geometry tutorial, kind of in depth. So yeah, it's not like super basic. Okay, then since we're using a PBR, say like here we're using a PBR, I need to get tangent. So we are adding tangent here. Okay, so this is about the SOP compiling, which can be a little bit confusing. But let's see these things in action, and then you will realize why maybe it gets so complex. So you open it and you say Simo, you give me something that is broken. It's broken because you didn't engage the flex simulation. So please press 1. Okay, you wait a second, maybe your touch designer will freeze a bit because we are sampling a lot of points. Okay, then if you press 2, you are running the simulation. Okay, you see here we can pause, and yeah, we have a bit of relaxation after I pause. I'll show you later. Because we can analyze what is happening. So the chain pass and each primitive that was in between the travel of this chain get like the collision. This is made working in conjunction with the two physics engine touch designer offers. We are using the bullet for the chain and the bunny for the bunny collision. We are using flex. Okay, so let's analyze then what is happening inside of the physics tab here. Okay. We go inside here, and this is basically just the example you get from the snippets of the bullet solver, which I now open. And you can have the chain, okay, initialize, start, we have a chain, beautiful. Okay, a bullet solver is running on CPU, which can be scary, but there are some tricks to make it lighter. Okay, so if you go inside of this actor, and then in the Geo viewer we are having a lot of stuff shown, which are the collision handles. The collision handles for the bullet are like the SOP, the point from this SOP, okay, which are actually acting as a contour shape of this beautiful torus, okay. And this concept of using a stuff so to act another is really cool, because you can slow down the calculation without having anywhere results. So the torus is taking the measurement from this guy, which is actually the collision SOP parameter, is populating this guy in a box. I mean, it's this guy, yeah. You're populating the collision SOP of the actor, so we are creating the boundaries, okay. So if you don't know, the first, if you drop a torus, sphere, whatever, okay, and you use the first input of the sphere, you get the sphere squashed by this bounding box. So you take the bounding box of an object and you scale it. It's very handy. And so they're using the measurement of the colliders, so to scale the actual object, which will be represented. So this will slow down calculation a lot. So be smart about collider. This is the example derivative give us, okay, analyze it. Okay, then the bullet can output data through chop. We have bullet solver chop. We are reading the value we need with a select chop, and we are piping the value to the bunny. The bunny is actually this scene, okay, and here you can actually see the point. I don't know, yeah, okay, here you see the point, okay, because here we're actually simulating the point of the bunny. What are those points? Okay, those points are actually are coming from an attribute I am creating in shop context, translating it to that, going through chop, finally top, and those are the center of each primitive. Okay, the center of each primitive is then used to instance point in a flex actor. The flex has no gravity, so we will just wait for a collision basically. Okay, and this chain here, if I now want to see the simulation in action at this level, okay, you see we are breaking the point, okay, but this is not anymore a chain, are spheres, because I am actually copying and mimicking the movement I got from the bullet simulation and recompiling the real collider in the flex simulation using bullet solver data. Okay. You can do it manually with replicator, whatever. This is an example. I just drop a lot of geo. Okay, so those guy here are this guy. I mean, you got the point. Okay. Now it's simulating. I cannot move, but it's okay. Okay, so let's stay in the bunny side. Okay. Um, so we have the bunny. The bunny are point instantiated. Okay, and these instance are inside of an actor, and the actor can be an actor of a physics engine of touch designer, which we choose to use flex. Okay, there is a caveat here: you cannot make point too big, because if you, I mean, the mesh you are sampling in order to get the point, the center of each primitive, um, it cannot be so compact. Once for performance, two because you will trigger collision before. We have look. Okay, so now I start the simulation, and I mean I should start the simulation, and you see the point are not moving until I collide with something. Pardon, two should start exactly. Okay, so they stay there. Okay, then I reset the simulation. This is the flex parameters somewhere. It's here. Okay. No, flex solver parameter. This guy. Okay. We have particle radius. Okay, meaning those tiny particles have a radius, so they are treated as spheres. Okay, and so they can collide in 3D. Basically, I won't go smaller than this, maybe because it's not even allowed. But if I now make it like 10 times bigger, okay, and I run the simulation with this value as radius of our hypothetical collision spheres, like Paqueta style with the sensor we are doing with the flex, but with spheres in 3D. Okay, maybe they also can deal with this, so let's go very big. Okay. You see the bunny started colliding before because it's colliding with itself, okay, which is not a wanted behavior. This is why you need to, this is the caveat, you need to make it so small is the maximum small radius for a good calculation, and you need to manage with the number of your primitive, which is already really high, but it's okay. Okay, then the complex part, it's time for it. We are actually reading the point we are simulating with the flex, and each actor can output the position of what is happening inside this actor directly in top with a flex top. Okay. I am using elastic behavior for the forces. This component, I don't remember. I use it somewhere also in other project of my partner. It's like a sort of elastic. You have it in the geometry tools. It's the elastic engine. But here I'm using it to smooth stuff, and I'm here smoothing the position, but I'm also smoothing the force. Okay, so here is the force, here is the position, and here is the force from the actor simulation. Okay, I'm smoothing, and the force is going back to the actor, and the point are finally going in a GLSL material. Okay, which we can briefly read. And okay, so what is happening here is basically it's a kind of tricky, but there is a really beautiful concept that is we are reading an attribute we store in primitive level in a vertex, in the vertex. Okay, because you are passing the geometry and the GPU knows how to interpolate this kind of stuff, working with the primitive data. So the primitive knows which vertex has, so the vertex can interpolate an attribute. This is wonderful, okay? So those are primitive attributes which you are reading in the vertex. You're acting in the primitive after tessellation in the geometry shader. Here now we are acting only with the attribute of the primitive inside of the vertex. I hope this is clear, okay? So we are actually substituting P, which is the point position of each vertex, okay? And we are subtracting the center, the interpolated center of each primitive from all the vertices. So each vertex knows, okay? So we go in the center of the axis. If you then want to output this, you see everything going in the middle of the axis. So you squash everything to zero, okay? This is okay, because then you can do the trick of you have one dimension, you want to get a two-dimensional array, you need to do this. So we have a square for sampling, and we can sample with a square, you can sample a texture. So we can texel fetch the new center position, which is coming from a texture, okay? The texture that is handling the point collision. This is from, we are reading the flex here, okay? Reading flex, okay? And yeah, so and we add this, the new position to the center, so the text will come back and is waiting to be displaced from the flex, right? So the whole trick is like 1, 2, 3, 4, 5, 6 line of GLSL. Okay, add 2 more. Okay, 2 more. So I mean 10. Okay, so it's 10 line with the GLSL. You can move. It's primitive, singularly, and you don't care. It's beautiful. Okay, 10 line of GLSL. Okay, so now we go to the render, and you render. Simple, basic setup. You have a GPU time reader, which is parent to is addressing this example, okay? And it's also an Easter egg actually. Hey, I didn't realize. You have other projects. So if you are inside here, Easter egg, look at this. You press U, you go up, you have other stuff. Some are broken, some are not. This is really aspiring. It's from Quentin Bletton. It's the first time I got like, now it's flickering with Vulkan, but basically you see, I am creating geometry from nothing. This is doing a checkboard. The flicker is not intended, but you see we are generating geometry which is following the mouse real time, only in top with a trigger in the geometry shader, which is very cool. It's called the billboard technique, kind of. Here we have the elastic old version. Boing boing. It's all free, don't go and get it. And if you want to spend some money, you are more than welcome to do so. Yeah, volumes as well. Now volume nowadays are becoming hyped. I see no volume, but you have your rendering point, and they can become a peak, I guess. Yeah. Okay, so this is how I'm rendering volumes. It's a trick, it's only screen space, and you can get like kind of volumetrical appearance to your stuff. And they are just points. Okay, the trick here is with the line and the screen space normal, which are taking the light. So yeah, volume, no volume, it's free. Take it. Other stuff. Ah, yeah, this is cool. Okay, this is also not wanted behavior. This flickering, well, this is super cool. So you have this guy, which is a real-time geometry generated using a vertex shader and some top. And yeah, you can basically actually do crazy stuff with this. Now it's flickering, but you can make it like explode and then go back and then retreat. And this is like no volumetric stuff. It's real geometry. It's moving for real. So no trick. It's real geometry. Look at that. Okay, this is free for you. I hope you get the idea how much time I invest to do all these kind of things. Now you can use it for free. So I kindly ask to at least give me the credit if you use it and support me. Please. This is for free for you. What else? Yeah, transparent stuff. So, achieving like a glassy look. Okay, so here I'm coding a point light. That's what I teach in a workshop light. Yeah, this is all free. I actually forgot to delete it because I didn't want to overdo in the project, but I just discovered that it's here, so you can get it. It's in the same project I shared there. Thank you very much for your attention, and yeah, see you next time. Ciao.